Hi students, welcome to Max Point of View. Today we are going to solve each and every previous year questions from the chapter Refraction of Light at a Plane Surface. Before watching this video, you should have the prior knowledge about refraction of light at a plane surface. You should have the complete knowledge about it. Then only you will understand many questions here. See, you need to understand why we have to learn previous year papers. Why? Because the previous year paper questions are completely different from textbook questions. That is what we are going to understand. In order to understand that, you should have the complete knowledge about this chapter. Then only you will understand everything. If you haven't watched the videos are available in the description box. We have 4 different parts. Okay, part A, part B, part C, part D. You should know everything about all the parts. Then only this video will be very helpful for you. And we know we are starting from 2017 to 2025. Why not before 2017? Because the syllabus was completely different and the logical questions were less and direct questions were more before 2017. After that, logical questions are more and direct questions are less. That is why we are starting from 2017. Before going to the questions, this is very much important about refraction of light at a plane surface. This is a huge chapter. So every year minimum of 5 questions will be asked from this chapter. That is why previous year paper based on refraction of light at a plane surface is very important. You will understand how the questions are completely different from the textbook. So without wasting any time, we'll start with the first question. We'll start from 2017. In that first question, how is refractive index is related to real and apparent depth? See, this is very simple question. So we have one more sub question. First we'll solve the first one. They are asking us to write the relation between refractive index, real and apparent depth. See, when it comes to two physical quantities, okay, only two physical quantities, like what is the relation between or how refractive index is related to real depth or how refractive index is related to apparent depth. In these two questions, only two physical quantities are there, real depth and refractive index. That is one question. Apparent depth and refractive index, okay, that is one question. Here how many physical quantities we are talking about in both the questions? Two physical quantities. Then we have to write whether they are directly proportional or inversely proportional. But in this question, see the question properly, how refractive index is related to real depth and apparent depth. So refractive index, real depth and apparent depth, they are talking about three physical quantities. Whenever they talk about three physical quantities, we have to write the formula. Whenever they talk about two physical quantities, we have to write whether they are directly proportional or inversely proportional. Okay, this is the meaning. This is how you have to tackle the questions. Anyhow, in this question they are talking about three physical quantities like refractive index, real depth and apparent depth. We have to go for the formula. So refractive index is equal to, see, you have to write it in full form. You should not use the symbols in the exam. Real depth by apparent depth. The first question is done. Okay, now we'll go for the second sub question. Velocity of light in air and velocity of light in given medium. So again we have to talk about how refractive index is related to velocity of light in air and velocity of light in given medium. So again we are talking about three physical quantities, correct? One, how refractive index is related to refractive index. Second, velocity of light in air, second physical quantity. Third one, velocity of light in given medium, third physical quantity. Again we have to talk about the formula only. So mu is equal to C by V. Okay, what is mu? Mu is nothing but refractive index. What is C? Speed of light, the velocity of light in air or vacuum. Okay, see, when it comes to air or vacuum, the speed of light is not same. Okay, keep this in mind. Actually, when if you are talking practically, okay, velocity of light in vacuum is maximum compared to air. Okay, there is around 93,000 meter per second difference is there, but for calculation purpose, we assume velocity of light in air and vacuum as same. So here they can mention velocity of light in air or velocity of light in vacuum. For both the cases, we are using the symbol C. What is C? C represents velocity of light in air or vacuum. Only in air or vacuum we represent using the symbol C. In any other medium, velocity of light in glass, velocity of light in water, velocity of light in diamond or any liquid or anything, we use the symbol V. Okay, this is very much important. C we use it to represent velocity of light in air or vacuum, only in these two medium. In any other medium, we use the symbol V. Keep this in mind. Okay, you have to write it in full form. This is velocity. So you see the question, velocity of light in air, and V represents velocity of light in any given medium. That's it. Our next question, a ray of light travels from water to air as shown in the diagram given below. Water to air is very much important. Why? We are going to understand during the question. Copy the diagram and complete the path of ray given the critical angle for water is 48 degree. Okay. So here first thing we need to understand, we are talking about critical angle. Whenever we talk about critical angle and total internal reflection, keep this in mind. Critical angle and total internal reflection, the ray has to pass from denser medium to rarer medium. Keep this in mind. Here see, water and air. Compared to air, water is denser, so the light ray is moving from denser to rarer. So this question we can answer it. So this is the first important point, and this is how you have to analyze. Whenever critical angle and total internal reflection comes into picture, you have to see whether the light is coming from denser to rarer or rarer to denser. If it is from rarer to denser, whatever we have learnt about critical angle and total internal reflection, it will not work. That is why denser to rarer or rarer to denser is very much important. Next, now we'll go for the question. Copy the diagram and complete the path of ray. Given the critical angle of water is 48 degree. Okay, critical angle is 48 degree. That is what they have given. Now listen, how many students will become Bakra during the exam time? Listen, here they have given 48 degree. Correct. What is angle of incidence? I represents angle of incidence. Correct. What is angle of incidence? The angle between the normal and the incident ray. This is the incident ray and this is the normal. Correct. So what is the angle between them? That is angle of incidence. In this question they have given directly. Correct. That is how we can use it. But in some questions they will give you this angle. They will give you this angle. If they have given this angle, and if you think this angle is angle of incidence, then whatever you do, completely wrong. Why? Because this angle is not angle of incidence. Correct. You have to see, whenever they give the question, you should not assume whatever they have given everything is correct. No, you have to analyze the question properly. If this angle is given, okay, then angle of incidence will be this one, not this one. Then using this one, we have to find this one. Assume this is 42. Assume this is 42 degree. Okay, what is the total angle? That is 90. From here to here, that is 90. This is 42. Then this will be 90 minus 42. Will get the answer here, 48 degree. Understood? So you have to see what angle is given and what is required. Angle of incidence is required. In this question they have given. In some other question they will give you this angle. Using this one, you have to find this one. If you take this one for the calculation, everything is wrong. Okay, be very careful. Next, copy the diagram and complete the path. Okay, here the critical angle is 48 degree. Angle of incidence is also 48 degree. When angle of incidence is equal to critical angle, what happens? Refraction will happen. Refraction will happen. Listen, keep this in mind. When angle of incidence and critical angle both are equal, refraction will happen, but it is not a normal refraction. The angle of refraction will be 90 degree. So the ray of light will pass on the surface. This is important. Okay, if listen, if angle of incidence is little less than critical angle, assume now the critical angle is 48 degree. If okay, I is equal to 47 degree, then normal refraction almost close to this surface, normal refraction. Okay, but anyhow in this question angle of incidence is 48 degree and critical angle is 48 degree, both are equal. There will be refraction, but it will be on the surface of the medium, so that angle of refraction will be 90 degree. This is the basics we are talking about. That is why before solving any question you should have the prior knowledge. Okay, next, so here the diagram is done and given the critical angle, using that we have done the diagram. Then we'll go for the second question. State the condition so that total interreflection occurs in the above diagram. What is the condition for total interreflection? The angle of incidence should be greater than the critical angle. Correct? Should be greater than the critical angle. See, I'll revise it everything one more time. If the angle of incidence is less than the critical angle, assume less than 48 degree, then somewhere here refraction. If it is equal to critical angle, again refraction, but the angle of refraction will be 90 degree and refraction will be on the surface. And now they are asking for the condition for total internal reflection. For total internal reflection, angle of incidence should be greater than 48 degree. Should be greater than 48 degree, or you can write it as, okay, this is the precise answer for this question because angle is given, right? 48 degree. So this is the precise answer we are looking for. Some students will write angle of incidence should be greater than the critical angle. That is correct. This is a general equation. Okay, but here we have given the angle, right? So I have to specify the angle. That's it. Our next question. State the conditions for total internal reflection. See, when it comes to total internal reflection, every year minimum of 2 marks, one question will be there. Minimum of 2 marks. See, in olden days, like in 2017 and all, the questions were very direct. Correct? See, state the conditions for total internal reflection. Very simple question. But when it comes to after 2022-23, okay, the questions about total internal reflection every year they are asking, but it is not direct. That is the difference between before 2017 and now. Okay, this is very much important. That is the main reason why we are not solving before 2017. Whatever you solve before 2017, you may find 1 or 2 logical questions in one main. But now, okay, the complete almost 60 to 80% of the questions are logical. So you have to be very careful and understand the topic. You can easily get the answer. Now, what are the conditions for total interreflection? First thing, the ray has to enter from denser medium to rarer medium. That is the first condition. The ray has to enter from, the light ray has to enter from denser medium to rarer medium. Second one, the angle of incidence should be greater than the critical angle. That's it. These are the 2 conditions for total internal reflection. This is a very basic question. Our next question, the diagram below shows a point source P. This is the point source P. Okay. Inside a water container, 4 rays A, B, C, D starting from the source P are shown up to the water surface. So this is the diagram. See, very simple question. From a point P, 4 different light rays are going in 4 different angles. That is what they have shown in the diagram. Now, an important thing is this is from water to air. Water to air. So water compared to air, water is denser and air is rarer. Keep this in mind. So the light ray is coming from denser medium to rarer medium. This is very much important. Now, shown in the diagram, the path of these rays after striking the water surface, the critical angle, okay, of water surface is 48 degree. Okay, the critical angle is for this medium is 48 degree. These are the conditions they have given. We have to draw the paths after what happens after they cross this surface. See, now see, if you draw a normal, okay, normal, it will be like this, correct? Because the surface is very straight. If you keep the compass and draw the normal, you will get exactly the normal ray here, correct, on this incident ray. If the incident ray is on the normal, what is the angle of incidence? That will be 0, correct? That will be if the incident ray is on the normal. Okay, so in some questions they will give you the hint like this: a ray is incidented normally on the surface. That means what? Okay, ray is on the normal, the incident ray is on the normal, then angle of incidence will be 0. If the angle of incidence is 0, angle of refraction will also be 0. So the ray will pass exactly like this. The ray will pass exactly like this. Now we'll go for B. Wherever there is a point, okay, incident, draw the normal. Now we can easily say, see, so the ray C, the angle of incidence is given 48 degree. Initial first one angle of incidence was 0. This, the B is between 48 and 0, 48 and 0, correct? So B cannot be more than 48, correct? So it is going in order 0, some angle, and the ray C has 48 degree. So this is definitely less than 48 degree, and critical angle is given as 48 degree. If the angle of incidence is less than 48, okay, less than critical angle, what happens? It undergoes normal refraction. So normal refraction, okay, it goes away from the normal. Some students will think, okay, whether we write away from the normal or towards the normal, anyhow they are going to give marks. No, completely wrong. Why? Because the ray is moving from denser to rarer, then the speed of light or velocity of light will increase. If it is fast, okay, if it is fast, it moves away from the normal. That you should know. The light is entering from denser to rarer, so it moves away from the normal. These are the very simple basics you should know. Then the ray C, okay, here the angle of incidence is 48 degree and the critical angle is also 48 degree. When the angle of incidence is equal to critical angle, then again refraction, but the refraction will be on the surface and the angle of refraction will be 90 degree. This you should know. These are the basics. Now the last one, the ray D. Okay, here the angle of incidence at this point, okay, here this angle we require. This angle we can easily say it is more than 48 degree. More than 48 degree. So that is nothing but angle of incidence is greater than the critical angle, then total internal reflection will happen. Whatever the angle we have here, the same angle we are going to get here. Angle of incidence will be equal to angle of reflection. Okay, that you should know. Okay, this is the diagram they are looking for. So part A is done. Part B. Name the phenomenon which the rays B and D exhibit. Okay, according to the diagram, B exhibit normal refraction, so refraction, and C, no, they are not talking about C, they are talking about D. D, what kind of this one phenomenon it is exhibiting? The D is nothing but total internal reflection. Total internal reflection. That's it. See, if you have the basic knowledge, you can answer these kind of questions. Our next question. Draw a ray diagram to show the refraction of monochromatic ray through a prism when it suffers minimum deviation. Here, very important two keywords. One is monochromatic. Second one is suffers minimum deviation. This is very much important. Okay. So, the important thing is, why these two are important, I'll show you. Okay, you have to use a scale and draw, then only you will get complete marks. Okay, when it comes to ray diagram means what? A ray, using the light rays, correct? That is why it is called as a ray diagram. Okay, the ray, whenever you are drawing the ray diagram, you have to use the scale, because the rays has to be straight, and wherever it requires, okay, the prism has to be very straight, all these sides has to be very straight. So this is very much important. Now, naming the prism A, B, C, this is also important. It has to be labeled. Always the ray diagrams has to be labeled. So we have given the letters for all the vertex. Okay, that is done. Now a ray of light is incident. Okay, the ray of light is incident. You give one more name for this one, PQ. PQ is the incident ray. Okay, now here draw the normal. This has to be very straight. This line has to be parallel to the base. This line has to be parallel to the base. Only when, see, the refracted ray, see, inside there is a refraction, correct? Because there is a change in path. See, if there was no medium, the light would have traveled in this angle, correct? Because of the medium, it is getting refracted, and it has to be parallel to the base only when they mention minimum deviation. This is very, very important. Okay, minimum deviation. At minimum deviation, the refracted ray inside the prism has to be parallel to the base. Many students will not follow this one. This diagram is for 2 or 3 marks. The complete marks you are going to lose. They'll just draw it. Okay, like this, in some angle, again one more, some angle, correct? The emergent ray with some angle, then you will think you will going to get full marks, correct? If it is not minimum deviation, normal deviation, any deviation except minimum deviation, this will not be parallel to the base. Now anyhow they have mentioned minimum deviation, the refracted ray has to be parallel to the base. Okay, that is the difference between learning the concepts from maths point of view and some website. If you see some website, they will give you the diagram, they were not going to teach you this has to be parallel to the base, correct? Then what you'll do, you will think see, you will draw it like this, here some angle, done. You will think this is correct. Completely wrong, because this ray has to be parallel to this one. Okay, the examiner who is correcting your paper, the evaluator, they'll check whether this is parallel to this one, then only they will allot you the mark. And why monochromatic light is important? Because if we pass, okay, polychromatic light, polychromatic means, what is monochromatic? Single color light, any color, right? Maybe red or blue or green, any color, single color. What do you mean by polychromatic? It has many colors inside it. When we pass polychromatic light, along with the refraction, dispersion will also happen. What is dispersion? Splitting of colors, correct? Splitting of colors. Anyhow, it is a monochromatic, that is why there is no splitting of colors. If they mention polychromatic, then you have to show different colors, okay, different rays inside the prism. Okay, dispersion, again outside it has to refract. Now anyhow it is monochromatic. We have some questions, we'll go for it, don't worry. Now this will be PQ or as emergent ray, done. Okay, here at this incidence, draw one more normal, done. This is the diagram they are looking for. The important thing is monochromatic. Because of that monochromatic, there is no dispersion, there is no splitting of colors inside the prism. Okay, that is the first important thing. Minimum deviation, when they mention minimum deviation, this refracted ray inside the prism has to be parallel to the base of the prism. Okay, and one more thing, use a scale and pencil. Don't use a pen to draw the ray diagrams. Now we'll move on to 2018. How does the angle of deviation formed by a prism changes with increase in angle of incidence? With increase in angle of incidence, what happens to angle of deviation when we pass a light through a prism? Okay, this is their question. How these two are related, whether that is directly proportional or inversely proportional. This is a conceptual based question. Why? Because if you have the basic knowledge, you can easily answer it. There is no need to think much about it. This is a direct question. Okay, angle of incidence increases. When the angle of incidence increases, the deviation, we cannot give the answer like it is directly proportional or inversely proportional only for this question. Why? Because first, see what happens when you increase the angle of incidence, angle of deviation first decreases. Okay, answer for this question. This is how you have to answer. When you increase the angle of incidence, the angle of deviation first decreases, reaches the minimum deviation, and again it increases. That's it. Second one, draw a graph showing the variation of angle of deviation with angle of incidence at the prism surface. Whatever we have mentioned, okay, we have to show them in the on the graph way. Okay, see, again use the scale. So here you need to see, not only drawing the graph is important. Okay, you have to know where you have to write the coordinates. So this is angle of incidence, this is angle of deviation. Okay, and this is the symbol for deviation, angle of deviation, angle of incidence. So if we go in this way, that means angle of incidence is increasing, correct? If you go in this way, angle of incidence keeps on increasing. What we have written here, first, as the angle of incidence increases, angle of deviation, this one, first decreases, reaches the minimum point, and again it starts increasing. That's it. The same thing in the graphical representation. Done. Our next question, why is the ratio of velocities of light of wavelengths 4000 angstrom and 8000 angstrom in vacuum is 1:1? If you understand the question, then only you can write the answer properly, correct? They are telling why is the ratio of velocities of light. To assume there is a two different light rays. One wavelength is 4000 angstrom and other wavelength is 8000 angstrom. They are traveling in vacuum. Why their speed velocities are in the ratio 1:1? What do you mean by 1:1? That means same values. That means if you combine all these hints into one single part, then you will get the answer easily. That means the velocities have two different lights, even though they have two different wavelengths, in the vacuum they travel with the same speed. Why? That is their question. Speed of all the colors in vacuum is same because there is no atmosphere in the vacuum to affect the speed of light in vacuum. That's it. So this is how you have to write. Speed of all the colors of light in vacuum is same. Keep that in mind. Sometimes they will confuse you with different colors. Which color has maximum speed in vacuum? Either red or blue. We know speed of all the colors, not only colors. When it comes to electromagnetic spectrum, like infrared ray, UV rays, microwaves, all those radiations, even though radiations as well as the colors will have the same speed in vacuum. Keep that in mind. All the radiations, all the colors will travel with the same speed in vacuum. This is very much important. See the word, look for the word vacuum in the question. If it is not there, then it is according to their wavelengths. But when it comes to vacuum, all the colors and all the radiations will travel in the same speed. Okay, why? Because the vacuum doesn't have any atmosphere. This is the reason. We have one more question. Which of the above wavelengths has higher frequency? Okay, they are talking about higher frequency. We know frequency, okay, this is not the answer. Frequency and wavelengths are inversely proportional. This is the relationship. Frequency and wavelengths are inversely proportional. So whichever has the highest wavelength, that will have the lowest frequency. See, out of 8000 angstrom and 4000 angstrom, which has maximum wavelength 8000 angstrom, so that will have minimum frequency. But in the question they are asking for higher frequency. For a higher frequency, it should have the minimum frequency, minimum wavelength. So the color with less wavelength or minimum wavelength will have maximum frequency, because these two are inversely proportional. See, in this question they are not asking for the reason. Don't write one. Very simple. If they are asking for the reason, you write the reason. If they are not asking for the reason, see, the question is very simple. Which of the above wavelengths has a higher frequency? The answer is 4000 Armstrong light. That's it. So this is the answer. So this is also not required. This is for your knowledge. You should know these two are inversely proportional. Then only you can answer these kind of questions. That is why I always tell you, when it comes to previous year papers, you should have the prior knowledge. Our next question, the following diagram shows a 60 degree, 30 degree, 90 degree glass prism of critical angle 42. So the critical angle is 42 degree. Copy the diagram and complete the path of incident ray AB emerging out of the prism, marking the angle of incidence on each surface. Okay, we'll do that. Now listen, see, this is about total internal reflection in a glass prism. Okay, this concept you should know. Okay, I have taught you properly in the concept video. If you know how to continue with the diagram, then only you will understand this solution here, because this is not about knowledge, this is about some procedures. What happens if it is less than the critical angle? What happens if it is equal to critical angle? What happens if the angle of incidence is more than the critical angle? How to draw it inside the prism? All those things, it is a procedure. Okay, that I have taught you in the concept video. If you know that, then only this question is going to be useful. See, in textbook we have some prism. Even though the angle of incidence is there and there will be no total internal reflection inside the prism, this is one of those cases. This is one of those cases. There will be no total internal reflection inside that. That is what we are going to learn how it is possible now. Now listen. So when the angle of incidence is normal, see, now they have clearly mentioned this is 90 degree, and whenever they give you the prism, triangular prism, whatever the angle it is, if they have given the angle, then it is okay. If they have not given the angles, first you have to write the angles. They will give you some hints. See, like this, if this is 90, okay, they'll show you like this. See, the box angle, you know, this is the basics of mathematics. If they have given the angle in terms of box, that is 90 degree. So this is 90, and if they will give you this one or this one, sometimes this one or this one. In this question they have given both, that is okay. If they have given this as 60, you mark this as 30. If they have given this as 30, you mark this as 60. The total angle should be 180 degree. That's it. Okay, now okay, they have given the angles, we can aramse proceed. So if the angle of incidence is 0, angle of incidence is 0. What do you mean by angle of incidence is 0? That means it is on the normal. For wherever it is hitting the surface, okay, wherever it hits, we have to keep the protractor and draw the normal. If you keep the protractor here, okay, draw the normal, it will show exactly on it. Okay, so now the angle of incidence is 0. Okay, now it passes without deviation. This is very much important. Okay, now once it hits here, you have to keep the protractor. See, wherever it touches the surface, here also it has touched the surface, we have kept a protractor. Now again it is touching the surface, you keep the protractor and draw the normal. Now which angle we want, that is important. Which angle we want? We have two angles, this one and this one. Which angle we want? We want this angle. Why? Because what is this angle? This is the angle of incidence at this surface. See, this is the angle of incidence at this surface. Again it is touching one more surface, so we have to find the angle of incidence, correct? So why this angle is important? Because this is the angle of incidence. See, this is the angle of incidence. How? What is angle of incidence? It is the angle between the incident ray, this is the incident ray, and the normal. If you take this angle, then everything will become wrong. This is the basic of drawing the ray diagrams. Okay, that is what we have learnt in the concept video. See, I know in many schools they will confuse you, few teachers will confuse you this concept. So that is why I have found a simple solution. Okay, simple procedures how to follow that. That is what I have taught you in concept video. Learn it and come back to this video, definitely will understand, because every year there will be one question like this for 3 to 4 marks compulsory. Okay, you will get to know every year. This anyhow we are in 2018, right? So you will get to know. Now this angle is important. How to find this angle? This ray, incident ray, as divided has formed a triangle. If you find the angles of a triangle, then we will get it. This is what we have learned in concept video. We know this is 90 degree because it is a straight line, and this is a straight line. This is 90 degree and this is 30 degree. Then definitely this will be 60 degree. 60 degree, correct. Now we know from the surface till this normal. Okay, from this surface till the normal. See, this normal will divide, okay, the complete everything into 4 different 90 degrees. 190 degree, okay, here 190 degree, second 90 degree, this complete thing is 90 degree, and this outside is also 90 degree. So this complete thing, okay, from the surface till here it is 90. Out of 90, one part is 60, then definitely it will be 30. Definitely it will be 30. If this is 30, what is angle of incidence is 30, critical angle is 42. If the angle of incidence is less than the critical angle, then no total internal reflection, it will be normal refraction. Now the ray will go outside. Okay, whenever it is going outside, there are 3 possible ways. It can go straight, it can go towards the normal, it can go away from the normal. According to you, which is correct? If you write straightly, completely wrong. Why? Because there is a difference in medium. It is a glass prism and it is coming outside, correct? Coming outside. So the center one is not possible. So few students will get confused whether to write towards the normal or away from the normal. That is why, okay, the last mark they will see, okay, if it is towards the normal or away from the normal, which is correct, for only for that they will give you marks. Now listen, we got now straight line is not possible because there is a change in medium, glass to air. So it has to be either this one or this one. This ray is towards the normal, this is away from the normal. What happens when a ray moves from denser to rarer? Now this ray is inside the glass prism, so it is denser. Now it is going outside, that is rarer. Denser to rarer, speed increases, correct? Speed of light increases. If the speed of light increases, it moves away from the normal. This you should know. If it is moving away from the normal, this is also wrong. Okay, so this is the correct diagram. That's it. This is how you need to analyze during the exam. So for this one, 3 to 4 marks every year based on total internal reflection in a prism. You will get one diagram. Now we'll move on to 2019. What is the relation between the refractive index of water with respect to air? The refractive index of water with respect to air, and the refractive index of air with respect to water. Refractive index of air with respect to water. What is the relation between these two? That is the question. Okay, listen. This is one refractive index and this is one refractive index. Here you need to understand the ray is entering from air to water. The ray is entering from air to water. Here the ray is entering from water to air. So what is the relation between these two? First tell me what these two concepts, okay, these two refractive index are related to which principle? Okay, which principle in refraction? Principle of reversibility. The ray is entering from air to water and again it is entering from water to air. So principle of reversibility, this concept you should know, because in one of the year, I think in 2023 or 24, they have given the answer and they are asking for what is the principle we have used here. So whenever a ray is entering from two different mediums, from first medium to second, again from second to first, this principle is considered as principle of reversibility. Keep this in mind. Anyhow, here they are not asking, they are asking the relation between these two. Very simple. The answer is, this is not the answer, the answer is, you can write any one first, is equal to 1 by mu WA. This is the relation. They are inversely proportional. They are inversely proportional. Okay, the first question is done. Second one, this is the basics. This is what we have learned in concepts. Then if the refractive index of water with respect to air, okay, water with respect to air is 5 by 3 and calculate the refractive index of air with respect to water. We need to find the refractive index of this one. Just now we have understood these two are inversely proportional. If okay, here refractive index of water with respect to air is 5 by 3. This you should know how to write it. 5 by 3. Then refractive index of air with respect to water will be, we know they are inversely proportional. That means we have to take the reciprocal. Answer will be, that's it. So this is very simple question. Okay, principle of reversibility. If this refractive index is 5 by 3, we just take the reciprocal, we will get the answer. Why we have to take the reciprocal? Because these two are inversely proportional. See, we will apply the values whatever they have given here. Air with respect to water they have, water with respect to air they have given, that is 5 by 3. 5 by 3 is equal to mu water. Okay, this one we need to find the refractive index of this one. You move this one here and this one here, then is equal to 1 by 5 by 3. So 1 by 5 by 3 is nothing but 3 by 5. You don't have to show all these things. You can write the answer directly, because anyhow this is only for 1 mark question. If you have the knowledge, you can write the answer directly. If there is no formula, if there is formula, you have to substitute and get it. Here there is no formula, you can aramse get it, because these two are inversely proportional. Okay, so reason also they are not asking. If you write this one, see, when it comes to A, okay, A, you write only this much. When it comes to B, you write only this much. That is enough. All these things are also not required. That's it. Our next question, define critical angle. We have one more sub question. We'll go for it later. First, we'll define it. Critical angle. It is the angle of incidence from a denser medium to the rarer medium, corresponds to angle of refraction at 90 degree. This is the answer you are going to write. It is the angle of incidence. Critical angle is the angle of incidence from a denser to rarer. Two keywords in this statement, denser to rarer, and the refraction is at 90 degree. So these are the two important keywords. Using these two, you frame any proper English sentence, you will get full marks. Keywords, denser to rarer, refraction at 90 degree. These are the two keywords. Next, we have one more sub question. A is done. B. Next, it's not done. State one important factor which affects the critical angle of a given medium. See, there are many factors, okay, many factors, but they are asking for important factors. When it comes to critical angle, there is one relation, okay, that is nothing but formula is given in the textbook. Using that, we have to answer this one. The answer is refractive index. Okay, wavelength will also affect critical angle, temperature will also affect it, okay, and nature of the medium. Okay, nature of the medium is nothing but refractive index. Okay, so all those things also will affect it, but important factor is refractive index. Why? Because, okay, there is a formula in the textbook. This is the formula is there in the textbook. That means C represents critical angle and mu represents refractive index. They are asking state one factor. They are not asking state the factor and how it is affecting it. Are they asking how these two are related? Whether they are directly proportional or inversely proportional, that is not the question. State one factor which affects. That means you just name the factor, that is done. Okay, that is okay. If they are asking, write the relation also, write the relation between the factors stated by you, how refractive index is related to critical angle, then you have to write these two are inversely proportional. If in this question they are not asking, so don't write one. Our next question, the diagram below shows a light source P embedded in a rectangular glass block of ABCD of critical angle 42. C is equal to 42 degree. Complete the path of ray PQ till it emerges out of the block. Write the necessary angles. So the ray is incidented from denser. It is inside the glass slab. So it is inside the denser. Outside it is air. So it is rarer medium. So the light ray is in denser to rarer. We have to complete the diagram. Now, a simple mistake what students will do. First thing, whenever they are copying the diagram, they will change the letters A, B, C, D. Okay, they'll write this as A, B, C, D. That is one way to lose marks. Then we have given the ray PQ. They will take X, Y. Some other letters they will take. This is how you are going to lose marks. Whatever the ray we have given, okay, in the question, you have to use that. If we are asking you to draw it from the scratch, from the beginning without, okay, you assume the diagram is not given, okay, you have to start from the scratch. That means you have to start from the beginning, then you can use whatever the letters you want. If we have given PQ, you have to use PQ. If you use XY or MN, then completely wrong, you're going to lose marks. If it is for 3 marks, why do you want to lose 1 or 2 marks in that? Okay, very simple, no? So whatever the diagram they have given, copy it properly. Okay, critical angle is 42 degree. It is for traveling from denser to rarer. It has to come outside. That is our aim. Okay, and we have to mention the angles which is necessary. Wherever there is an angle, we have to mention it. Now listen. So it is hitting here, so draw the normal. Angle of incidence 42 degree is given, so we can say go for it. If the angle of incidence is 42, which is equal to the critical angle, okay, it goes here. Correct? Completely wrong. Why? Because this is not the angle of incidence, this is the angle of incidence. This is very, very much important. See, this is the, okay, this is given to distract you. Distractor, it's a distractor. They have not given the exact angle. Okay, they have given the, okay, angle which is not important. The important angle is here, this one. Using this one, we have to draw. We have to find the angles. If you start, okay, if you have drawn like that, okay, using this angle, completely 3 marks you will lose it. Okay, so now this is 42 degree. We know from this surface till this normal. Till this normal, it is 90 degree. Out of 90, one angle is 42, the other angle will be 48. 90 minus 42 is 48. This is how we got it. Okay, now we got the angle of incidence. Now see, angle of incidence is 48, critical angle is 42. Angle of incidence is greater than critical angle, so total internal reflection at an angle 48 degree, again with the same angle 48 degree. Now it is hitting here, correct? Now anyhow it is a straight line. Keep the protractor wherever it hits it, keep the protractor, okay, protractor, draw the normal. Now which angle we want? See, do we want this angle or this angle? Always the angle between the incident ray. Now this is the incident ray, angle between the incident ray and the normal. This angle we want. How to find that angle? Very simple. This ray has created one triangle. Find the angles of triangle, you will get it. We know from the normal till the surface, this complete angle is 90 degree. One is 48. This will be 42. And we can clearly say this is 90 degree. Correct? And if this is 90, 42, what is the total angle of a triangle? 180 degree. 90 plus 42, and some angle should be equal to 180 degree, that will be 48. And we know from this surface, this line, okay, this line, from that line to normal it is 90 degree, and one of the angle is 48, the remaining will be 42. This total angle is 90, out of which one is 48, this is 42. So now the angle of incidence is 42. This is how we have finding it. This is what we are learnt in concept video. So angle of incidence is 42, which is equal to the critical angle. Then the ray, okay, if the angle of incidence is equal to critical angle, then the ray will come out of the glass block on the surface. Whenever it is critical angle, we have to mention this 90 degree. Angle of refraction will be equal to 90 degree. So this is the ray which is coming out. Okay, that's it. Our next question, complete the path of ray AB through a glass prism PQR till it emerges out of the prism, given the critical angle is 42 degree. Okay, see, actually this question is taken from the textbook. This question I have taught you in the concept video. This is the textbook question. Okay, I have taught this textbook means not in the theory solution, it is actually in the concept video. There I have taught you properly. Okay, anyhow, if you have the knowledge, anyhow you have seen the video, this is a very simple question. If it is okay, not there in the textbook, we can draw it here, correct? What is the difference between previous year paper and the textbook? If the question, we are going to learn how they are different, correct? Anyhow, this question is directly taken from the textbook. We are not going to solve it. This is the solution for it. And if you want to know how we got the solution, this is in part D of refraction of light, that too in concept video of part D. There you are going to learn it. I have taught you properly. Our next question: a ray of light falls normally on a rectangular glass slab. Okay, draw a ray diagram showing the path of ray till it emerges out of the lab. Okay, a glass slab. Whenever you are drawing a ray diagram, use scale A, B, C, D. See, in this question we are drawing it, okay, from the scratch, from the beginning. So you can name it however you want. If they have given A, B, C, D in different orientation, if A starts here, B, C, D, then you have to take the same thing from the question paper. If we are telling you to draw from the scratch, from the beginning, you can name it however you want. Okay, now a glass slab is done. A ray of light falls normally. What do you mean by normally? Normally means, okay, you keep any protractor here and draw the normal. A ray of light falling normally. Normally means on the normal. These are the keywords. Okay, so now a ray of light is now falling normally, so that means angle of incidence is 0. If the angle of incidence is 0, angle of refraction is also 0. Okay, then again the ray is going here, it comes out. Okay, again at this surface you keep the protractor and draw the normal. Again it is on the normal, so it comes out like this. Very simple question. You name the ray P, Q, okay, R, S. That's it. The emergent ray is RS. Emergent ray means the ray which is coming out of the glass slab. That's it. Our next question: a pond appears to be 2.7 meter deep. If the refractive index of water is 4/3, find the actual depth of the pond. Here few students will get confused. How they'll get confused? Sometimes the wordings are important. The pond appears to be 2.7 meter deep. That means apparent depth. Okay, apparent depth is 2.7. In some cases, the same wordings, okay, will give you different meaning. Assume there is a coin, okay, which is inside a pond. It appears to be raised 2.7 meter. It appears to be raised. See, whenever you see this word appears to be raised, that word raised, that means they are talking about shift. In this question, they have not used that word. A pond appears to be. Appears to be is apparent depth. Appears to be raised, that is shift. In one of the questions, we are going to learn that. Okay, so this is the difference. This is how you need to understand the concept. So it appears to be 2.7 meter deep. That means apparent depth is 2.7 meter, and refractive index is given. That is 4/3. We have to find the real depth. Okay, this is for 2 mark. Very simple. In simple way we can get the answer. So what is the relation? Mu is equal to real depth by apparent depth. What is real depth? That is what we need to find. So R is equal to mu into A. What is mu? That is 4/3 into, okay, 4/3 into 2.7. Answer will be 3.6 meters. That's it. Our next question: the wavelengths of light of red and blue colors are nearly 7.8 into 10 power minus 7 and that is meters, and 4.8 into 10 power minus 7 meter respectively. So red and blue colors are given, and the wavelengths of red and blue are also given. Now we'll go for the question. Okay, which color has the greatest speed in vacuum? We know in vacuum all the colors and all the radiations means infrared, microwave, UV rays, all the colors and all the radiations in vacuum will travel with the same speed. Keep this in mind. The vacuum, all the colors and all the radiations will travel with the same speed. Here they are asking which color has the greatest speed. Both the colors. Both the colors. Okay, both the colors will travel at the same speed. So there is no greatest and lowest speed in vacuum. Okay, then when it comes to second question, which color has the greatest speed in glass? Now glass is a medium, vacuum was not a medium, correct? Glass is a medium. So when it comes to any medium except vacuum or air, see sometimes they will mention, instead of vacuum they mention which color has the greatest speed in air. All the colors and all the radiations will travel with the same speed in air or vacuum. In both the cases they will travel in the same speed, except air or vacuum. In any medium, okay, it depends upon wavelength. More the wavelength, more will be the speed. In the given case, okay, red and blue are given. Which has more wavelength? Red has more wavelength, that is 7.8, and this one blue has 4.8 into 10 power minus 7. So red has maximum wavelength, so it has maximum speed, greater speed in glass. So answer is red. Speed and wavelengths are directly proportional. More the wavelength, more will be the speed. But when it comes to vacuum, wavelength will not affect the speed. All the colors will have the same speed. That is 3 into 10 power 8 meter per second. All the colors and all the radiation will travel with this speed, 3 into 10 power 8 meter per second. Our next question, a diver in water looks obliquely at an object AB in air. Okay, first we need to know what you mean by obliquely. Obliquely means he is not looking, okay, from top view like this. So it is on the normal angle of incidency. I am looking exactly straight. So this is normal, looking normally. Obliquely means at some angle. The object is not exactly down, it is somewhere there, obliquely. Obliquely means I am looking at some angle. Some angle is there, we don't know the angle, that is the meaning. That is nothing but obliquely. Obliquely means we are looking at some object with some angle. If you look at it directly like this, okay, I'm looking at it normally, directly from the top view, correct? This is normally, with some angle we call it as obliquely. Many students just by looking at this word obliquely assume this question is in part B. Okay, you don't know the meaning of obliquely. So you know the concept and you don't know the meaning of obliquely, so you will think, so there is something wrong in this question, so I don't have to choose this question. And other remaining questions in part B, we know in part B, in one main we have 3 questions and 2 questions are very easy for you, and this question you think because of the word obliquely you are going to lose marks. So that is why in physics, whenever you are learning the concept, you learn the meaning of everything, of all the words, then everything will be easy for you. Okay, now obliquely means, so we are looking at some angle. Now the important thing is the diver is inside the water. The diver is inside the water and he is looking at some object AB which is outside, that is air. So here we need to know, whenever the person is inside the denser medium, he is looking from the denser to rarer medium. Now here we need to know real depth will be lesser than the apparent depth. This you should know. Okay, assume there is a coin inside a aquarium. Aquarium is there. I'm looking from outside, from air to denser. I'm looking from air and the object is a denser, air to denser. Okay, we are seeing from air to denser, then apparent depth will be less than the real depth. Now in this case, the person is in denser medium, the object is in rarer medium. Okay, he is in water and he is looking at the object in air, then apparent depth will be greater than the real depth. This concept you should know, then only we can answer these kind of questions. If we know the concept or answer, we can answer it. Listen, now he is looking from here and we know whenever light touches the surface here, okay, it has to refract, correct? Again it has to refract. Now the speed of light is getting slowed down, correct? So it is from rarer to denser, the speed has to reduce. So when the speed is getting reduced, it moves towards the normal. Whenever it moves towards the normal, extend these 2 rays. extend these two rays wherever these two meets, that length, okay, this will be the, okay, this is the length they are going to see. So this is the length of an object he is going to see. So assume the object is 5 centimeter. Okay, actual depth, actual size of the object is 5 centimeter. Okay, he will see it as more than 5, more than 5. Why? Because he is in denser medium, okay, and the object is in rarer medium. Then this is the real depth and this is the apparent depth. We know from the concept, we got to know, if the object is in rarer medium and the person is in denser medium, the apparent depth will be greater than the real depth. This is the diagram they are looking for. Just extend, see, once you draw the refracted rays, just extend it back in the same angle. Keep the scale and extend it back, then you will get the answer easily. Our next question, complete the path of monochromatic light, monochromatic single color light ray AB, okay, incident on the surface PQ of equilateral prism. So everything is 60, 60 and 60. Prism PQR till it emerges out of the prism due to refraction. Now listen, important thing is monochromatic. Correct, monochromatic means single color. When a single color light goes in, it comes out of single color only. If it is polychromatic, then it will split into different colors. Okay, many students will get confused. When I'm going to split the colors, when they mention polychromatic, or they will give you one incident ray. In this incident ray, they will mention 3 different colors. Okay, 3 different colors like red, yellow, blue, then it will get splitted into different colors. Now anyhow it is a monochromatic, there is no splitting, that means there is no dispersion, only refraction. Now listen, okay, many students will do this mistake. Whenever they give you the incident ray, they will draw it like this and they will draw it like this. Okay, do you think this is correct? This is completely wrong. Why? Because the refracted ray is parallel to the base. The refracted ray is parallel to the base. That is wrong. The refracted ray will be parallel to the base only when the ray is undergoing minimum deviation. So in the question, do you see any minimum deviation word? No, then the refracted ray will not be parallel to the base. Okay, whenever we are drawing the ray diagram, use the scale and pencil. Okay, now the refracted ray, see here in this case, the refracted ray is parallel to the base. This is completely wrong. Okay, why? Because only in minimum deviation the refracted ray will be parallel to the base. In the question they have not mentioned it is minimum deviation, so there should be some angle, it should not be parallel. There should not, okay, it should not be parallel. The refracted ray should not be parallel. So if there was no medium, the light would have gone like this, correct? Now because of the medium, okay, instead of going like this, it goes here somewhere, and again there is a change in medium, so it comes out. So this is AB, C and D. AB is the incident ray, BC is the refracted ray, and CD is the emergent ray. That's it. So we don't want any angle, just a diagram is required. That's it. Now we'll move on to 2023. The diagram below shows 2 parallel rays. A is orange. Okay, this is orange, A, and this is ray B, ray A. Okay, and B is blue. Incident from air on glass boundary, and air glass boundary, from air to glass it is incidented. Now copy and complete the path of rays of AB. Okay, we have one more question. First we'll complete the diagram. Whenever there is a incident, whenever you see a point of incidence, draw a normal. Now here many students will think however they draw it, they are going to get marks. Completely wrong. Okay, orange has more wavelength than blue color. Orange has more wavelength. That means speed of orange is more than blue. Correct. If more the speed, okay, the this one refracted ray, the deviation is also important. See, instead of going exactly like this, this will be little away from the normal, little away. Okay, now here anyhow the speed of blue is less, it moves towards the normal. Okay, see this difference. See here we have little big difference. Okay, big angle, here a small angle. This is very much important. The color which has maximum maximum wavelength compared to other color will have the angle of refraction will be little more. The color which has less wavelength, the angle of refraction will be less. Keep this in mind. Now again assume this is the other edge of the glass, then they are going to hit here. Okay, now again there is a point of incidence, draw the normal. Now they are moving from glass to air. Glass to air, they move away from the normal. They move away from the normal. Okay, that's it. So this is orange, right? So this is for orange. This is emergent rays of orange and blue. That's it. Now we have one more sub question. How do the speeds of these rays differ in glass? Okay, are the two refracted rays in glass parallel? Give reason. Okay, we have three different questions in question B only. How do the speeds of these rays differ in glass? Okay, first one, the diagram is done. Second one, in the question B we have sub question 1, sub question 2, sub question 3. Okay, how do the speeds of these rays differ in glass? Speed of orange, okay, speed of orange is greater than speed of blue. This one you have to write it in full form. Speed of orange is greater than speed of blue. If you write like this, you are not going to get marks. Here I don't have space, that's why I am writing like this. Second one, are the two refracted rays in glass parallel? No. What do you mean by parallel? The angle should be equal. If these angles are equal, then these would have been parallel, correct? If you extend, assume this this edge of the glass is not there. If you keep on extend it, somewhere they are going to meet, so they are not parallel. Our next question, a coin kept inside a water of refractive index 4/3. Okay, so here refractive index is 4/3. When viewed from air in vertical direction, appears to be raised by 3 mm. See, here these wordings are important. If they have given appears to be 3 mm, then upper end depth is given. Here appears to be raised. When you see this word appears to be raised, that means they are talking about shift. They are talking about shift. Shift is equal to 3 mm. This is important. If you take this as upper end depth, everything is wrong. Appears to be 3 mm is upper end depth. Appears to be raised, that means shift. This difference you should know. Then find the depth of the coin in water. So we have to find the depth of the water. That means the real depth we have to find. Okay, see, if the apparent depth is given without refractive index, what is shift? Shift is equal to real depth minus apparent depth. Apparent depth is not given, so we cannot use that formula. So what is the alternative formula we have? So this is shift is equal to real depth 1 minus 1 by mu. This is there in the formula. You can aram by heart it. Now substitute the values. See, what we want are correct. So first substitute the values. What is shift? Shift is 3. Okay, don't worry, you don't have to convert into meters. You can finally, whatever the answer you get, that will also be in millimeter. You can convert that later. Okay, now the shift is given as 3. Real depth we don't know. What is 1 minus 1 by mu? What is mu? That is 4/3. So 3 is equal to r 1 minus, sorry, this will become 3/4. 3/4, correct. See here, 1 minus 1 by 4/3 becomes, you have to take the reciprocal, so it becomes 1 minus 3/4. Okay, now what is 3/4? 3/4 is 75%. What is 100%? From 100%, 75% if you take it, 25% will be there. What is 25% in fractions? That is nothing but 1/4. So you can go for any type of calculation. Okay, this is 1/4. What do we want? R, you send this 4 that side. So R is equal to 3 into 4, that is 12 mm. You can keep the answer like this also, no need of converting into this one meters. If you want to convert into meters, divide it by 1000 because it is in millimeter, then 12 divided by 1000, whatever the answer you get, that the answer will be in terms of meter. If you keep it here also, you will get full marks. And we have one more sub question: how is the critical angle related to refractive index of a medium? This is we have learned in one of the questions, right? Critical angle is inversely proportional to refractive index. So this is A, B inversely proportional. Okay, critical angle is inversely proportional to refractive index. That's it. Our next question: the diagram below shows the ray OP traveling through an equilateral prism. Equilateral prism. This is very important. 60 degree. OP is traveling. Okay. Through a prism, equilateral prism of certain material. Calculate the value of I2. What is the I2? I2 is nothing but this angle. Okay, this is the normal, right? So this angle is I2. Then the angle of deviation is 43. Deviation is also given. See, what are the things given? We'll write it here. First, equilateral prism. Equilateral prism, A will be 60 degree. What is A? Angle of the prism. Why do we need this one? We will get to know because we are going to calculate something. This will be useful. Then angle of deviation is also given. How much is that? That is 43 degree. I2 we have to calculate. I1 is given. I1 is given, correct? That is 25 degree, correct? Completely wrong. I1 is not 25 degrees. See the diagram properly. See, what is I1? I1 is angle of incidence, the angle between incident ray and the normal. This angle is I1. This is not I1. This is a distractor. Using this one, we have to find I1. Understood? See, always whenever they give you the diagram, don't assume everything is correct. Everything is given. Analyze it. Okay, what is I1? Angle between the incident ray and the normal. See, this is the normal ray, right? The normal and the incident ray. This angle is considered as I1. What is this one? This is the other angle. From the normal till this surface, this is 90 degree. Out of 90 degree, if you take 25 degree, I1 will be 65 degree. 65 degree. Actually, in the question they have given 65 directly. I made this 25 just to make sure you are in the right path. You need to understand, okay, properly. Which is angle of incidence, which is angle of refraction. See, again, when it comes to angle of refraction, I could have taken this also angle of refraction, right? What is angle of refraction? Angle between the normal and the refracted ray. This is the refracted ray. Angle between that and the normal. You should not take this one as the refracted ray. Okay. Now, okay. I2 we need to find. I1 is 65. The difference you should know. Okay, which is angle of incidence, which is angle of refraction. If you don't know, in this way they are going to play a game with you. Okay, they will give you this angle. You think this is angle of incidence, and everything will become wrong. Because why everything will become wrong? In the first step, according to the formula, if you substitute, the first mark is always given for the substitution. See, I'll show you. I2 we need to find. What is the data given? A plus delta is equal to I1 plus I2. This is the formula, correct? See, here we have to substitute the values. A as 60, delta 43, and I1 65. We need to find I2. Instead of I1 65, if you take 25 here, okay, the first mark is given for the substitution. This is the substitution. Here, instead of taking 65, we take 25. Everything will become wrong. This question is for 2 to 3 marks. You have to be very careful. So this question is actually for 3 marks because we have one more sub question. Okay, so if you substitute all these things, and I2 will be equal to 38 degree. I2. Okay, I2 is nothing but the angle of emergent, and what do you call this QS as? See here, this is QS, correct? From QS, what you call this ray as? Okay, QS, that is emergent ray. This is emergent ray. So see, OP incident ray, OP incident ray, PQ refracted ray, QS emergent ray. In this way you should understand. Our next question, a ray of light is incident at 45 degree at an equilateral on an equilateral prism in the diagram below. Okay, this is the diagram. So we are not going to complete anything because it is already completed. Now we are going to answer some questions. Okay. Name the phenomenon exhibited by the ray of light when it enters and emerges out of the prism. See, here important thing. Now, many students will write refraction here. Correct. Refraction is correct, but here you have to see whether it is a monochromatic or polychromatic. Monochromatic. What do you mean by monochromatic light? It's a single light. Whenever a single light enters, the single light will come out. Correct. So, only refraction takes place. Here we can easily say it is polychromatic. We have many colors, correct? Okay, or dichromatic. We have two different colors. So see, a incident ray and it has splitted. You can see this diagram is given in the question. Okay, we can aram see it is getting splitted. So what do you mean by splitting of colors? Is called as dispersion. So what is the phenomenon? We can see here refraction and dispersion, both we can see. Okay, this is very important. If it is a monochromatic light, only refraction, there is no dispersion, correct? Here anyhow it is a, we have many colors, red, violet, only two colors. Okay, two colors dichromatic, so we have both refraction as well as dispersion. Now, state the cause for the above phenomenon mentioned by you. We have mentioned two phenomenon, so there will be two different causes, correct? No. From the concept, we have clearly learned that the cause of refraction and dispersion is same. The cause of dispersion and refraction is same. What is that they are asking? Change in speed of light. Change in speed of light in two different media, two different media. Media is the plural form of medium. Mediums, instead of saying mediums, we can say media. So change in speed of light, this is very much important. If you don't write this in a two different media also, that is okay. Change in speed of light is the important keyword. This is what you have to write in the exam. So if it is monochromatic, only refraction. Anyhow, we have two different colors. We have both the refraction as well as dispersion, and keep this in mind. The cause of refraction and dispersion is same. What is that? If they are asking you to write the cause of dispersion, change in speed of light in two different media. If they are asking for cause of refraction, again the answer remains same. Change in speed of light in two different media. That's it. So cause of refraction and dispersion is same. Keep that in mind. Our next question, a ray of light XY passes through a right angled isosceles prism as shown in below. See, I told you every year one question will be there on total internal reflection related to prism, correct? See, most of the time they will ask you to draw it. Here they have given the diagram, we have some questions, we have to answer them. Okay, so first analyze it. It is passing, okay. Angle of, if you keep the protractor here, okay, angle of incidence is 0, so it is passing without any deviation. So here it has taken a turn. Now we'll go for the question. What is the angle through which the incident ray deviates and emergent ray out of the prism? So they are asking what is the angle of deviation here in this case. See, angle of deviation and angle of deviation we can find using angle of incident and angle of emergent. Which is the emergent ray? This one, correct? And which is the incident ray? This one. You have to extend both. Okay, incident ray if you extend here, and emergent ray if you extend it backward, the angle between them. Okay, if you extend them both, you have to extend both. Incident ray, okay, this is what we have learnt in the concept video. Incident ray is here, you extend it, and this is the emergent ray, you extend it. What is the angle between them? Okay, angle between them, that is nothing but angle of deviation. So in this case it is 90 degree. That is done. Second one, name the instrument where this action of prism is put into use. See, this is what we have learnt in concept. This is this is based on knowledge. There is no need to analyze something. This is based on knowledge. So answer is periscope. For different angles, okay, if you turn this prism like this, the instrument will be different. Where we are using this, where we are going to use this instrument is different. So you have to understand the orientation also. Next, which prism surface will behave as a mirror? What do you mean by mirror? Mirror means reflection should happen. Reflection, correct? So where, say this is refraction going, okay, refraction means there should be some deviation. Anyhow, angle of incidence is 0, angle of refraction is also 0. So here it is taking a turn, correct? So there is a turn, that means it is reflecting back. See, if the angle of incidence is less than the critical angle, it would have gone out of the prism. Out of the prism. Here the angle of incidence is greater than the critical angle, that is why, okay, it is reflecting inside. So this surface reflecting inside. Where is that reflection is happening? On this surface AB. So reflection is nothing but mirror, correct? So will behave as a mirror. This surface will behave as a mirror. See, here reflection is taking place. So AB. So answer is AB. See, if you know the concept, anyhow we are not going to draw it. If you know all these concepts, it will take less than 1 minute to get 3 marks. Now we'll move on to 2024. Refractive index of glass with respect to water is 9/8. So this the way you write is also important. Refractive index of glass with respect to water. So water refractive index, okay, this is how you need to know how to write this one. This is what we have learnt in concept, okay, is 9/8. Find the refractive index of water with respect to glass. We need to find this refractive index. We know in one of the questions we have learned this one. See, from first medium to second medium the light is entering. Now from the second medium to first medium light is entering. So this is about principle of reversibility. Keep this in mind. So two different, see, refractive index and two different mediums are used in different ways, correct? Light is entering from first to second, second to first. This principle we call it as principle of reversibility. This is we have learnt in one of the question as well as in the concept video. So this is the answer they are looking for. What is the answer? See, we know G is 1 by mu GW. These two are inversely proportional. Then answer will be reciprocal of this one. In one of the video we have learnt. So you don't have to show all these things. This is the relation. Okay, using this relation we are answering it, correct? So if W mu G is 9/8, G mu W will be 8/9. Answer for first question is 8/9. This is a very simple question. Now we'll go for the second one. Name the principle used to find the value in part A. In part A we found some value. What is the principle we have used? Principle of reversibility. Okay, principle of reversibility. Next option, okay, question C. If we change the temperature of water, then will the ratio, okay, 9/8 remain the same? Write yes or no. See, they have clearly mentioned, write yes or no. You should not write, okay, in this way you should not write yes, it will not change, no, it will change. Why do you want to confuse the person who is evaluating your paper? They are clearly mentioned yes or no. You just write. If you feel it is yes, you write yes. If you feel it is no, you write no. Don't confuse. Don't write both and lose marks. Okay. So I will understand it. We change the temperature of water. See, if we change the temperature of water, what happens? Density changes, and we know density is directly proportional to refractive index. If density changes, refractive index also changes. So how temperature and refractive index are related? These two are inversely proportional. Keep this in mind. That is not required for this question, but you have to know temperature is inversely proportional to refractive index. Now here They are just asking yes or no. Answer is, they are asking, will the refractive index 9 by 8 remains the same? Answer is no, it will change. Okay, it will change, right? So answer is just no. You don't have to write no, it will change, no, it will not change, yes, it will change, yes, it will not change. All those dramas are not required. Just write yes or no. That's it. Our next question: light travels a distance of 10x units in T1 in vacuum. See, this is very much important. In vacuum, okay, it travels, okay, 10x, distance of 10x in time T1. Distance and time is given, so what we can find? Speed we can find, correct? Speed, okay, in vacuum, speed is equal to 10x. 10x is the distance traveled in time T1. See, in vacuum, 10x, this distance of 10x units in time T1, that is done. It travels a distance of x units in T2 in a denser medium. In denser medium, speed will be equal to, okay, x divided by T2. It travels x distance in time T2. This is their question. Okay. Now, using this information, answer the following questions. Now, light, okay, first one, light covers a distance of 20x. Light covers a distance of 20x units in time T1 in diamond. Listen, we know speed of light in vacuum is the highest. Speed of light in vacuum is the highest. So it is traveling 10x distance in time 1. In the question they have given, light covers a distance of 20x in time T1. Okay, in diamond, okay, do you think speed will be more in diamond compared to vacuum? No, right? Speed is maximum in vacuum. In vacuum only it is covering 10x. They are telling in diamond it is going to cover 20x distance. So now they are asking us to state true or false. Are they asking reason? No, then don't write one. They are just asking true or false. You don't have to write this word diamond also. In diamond also, we can easily say this is false. See how I am saying this is false? In vacuum only it is traveling 10x distance, and they are saying in diamond it is going to cover a distance of 20x. Do you think that is possible? That is not possible. So, and the time is same in vacuum as well as in diamond, T1 and T1. So it is completely wrong. Second one, calculate the refractive index of the medium in terms of T1 and T2. So now we have to calculate the refractive index. What is the formula for refractive index? For refractive index is equal to, we have real depth by apparent depth. So this is not related to real depth and apparent depth. So that is not the formula. And we have one more formula. Mu is equal to sin I by sin R. Sin I by sin R. So angle of refraction, incidence and angle of refraction is not given. So sin I by sin R I cannot use. What is the basic formula? Mu is equal to C by V. What is C? Speed of light in vacuum. Speed of light in vacuum. And what is V? Speed of light in any other medium. Correct? This is the basic formula for refractive index. In one of the questions we have used it. Okay, this is how first you need to understand which are the formulas we have for refractive index. Okay, you have to keep on ruling out if it is not related to this question. Okay, so speed of refractive index is equal to C by V. C is speed of light in vacuum or air, but V is speed of light in any other medium except air or vacuum. Now, speed of light in vacuum, just now we have found, that is 10x by T1. Then what is in any other medium? In denser medium, it can be anything. Okay, V represents speed of light in any medium except air or vacuum. Denser medium they have given. This is not air or vacuum. So speed of V represents speed of light in any other medium, that is x by 2. X by T2. Okay, x and x will get cancelled. Okay, x and x will get cancelled. So what do we have? 10 by T1. Okay, by 1 by T2. Therefore 10 T2 by T1. This is our final answer. This is the refractive index we are looking for. Our next question, A monochromatic ray of light is incidented on equilateral prism. Monochromatic, that means single color light. That is PQ. PQ is a single color light. Okay, at an incident at an equilateral prism placed at minimum deviation. Okay, minimum deviation and monochromatic is very much important. Monochromatic, there will be no dispersion, only refraction. Minimum deviation, that you should know. We have drawn one of the diagram based on minimum deviation with an angle of incidence 45 degree as shown in the diagram. First one, okay, copy the diagram and complete the path of ray PQ. See, when they say minimum deviation, the refracted ray should be parallel to the base. That's why I tell you, whenever you are drawing the ray diagram, use the scale and pencil. So this is the refracted ray, okay, will be parallel to the base only in minimum deviation. Assume the minimum deviation is not mentioned in this question. Okay, there should be small increase in angle. It should not be exactly straight. It will be somewhere here like this. If it is not mentioned minimum deviation, anyhow it is mentioned minimum deviation, this is not required. The refracted ray will be parallel. If this is not parallel, no one is going to give marks for you. Okay, they'll easily get to know you don't have the knowledge. Okay, so they will give you 0 mark. Now we have to complete it. So this will be the emergent ray, this will be the I2, that will be 45 degree. How did I write 45 degree? Do you think if you don't write 45 degree, will you get full marks? No. Why? Because in minimum deviation, we know, in minimum deviation, so diagram is done, in minimum deviation, 2 things you need to know. Okay, R1 will be equal to R2. R1 will be equal to R2. R1 will be equal to R2. Then I1 will be equal to I2. The third important thing will be the refracted ray inside the prism will be parallel to the base. These are the 3 things you should know. Okay, then we'll go for the second one. State the 2 factors on which angle of deviation depends. They are just asking us to state the factors. They are not asking you to how these factors are related to deviation. Just state the factor. First one is refractive index. You have to write it in full form, refractive index, then angle of incidence, then angle of prism. A represents angle of prism, and color or wavelength. Okay, I have used the symbols. You should not use the symbols in the exam. Mu, refractive index, angle of incidence, angle of prism, color or wavelength. You can write color or wavelength, any one is fine. So we have 4 factors. Here they are asking just for 2 factors. So you write any 2, that is fine. You will get full marks. Our next question, the diagram below shows the path of blue ray through the prism. See, blue ray is entered the prism and it is emergent out in this way. See, the ray blue color is on the surface. Okay, it is emerging out on the surface of the prism. That means, so angle of incidence is equal to the critical angle. If a ray is passing on the surface, that means the angle of incidence is equal to the critical angle. That you should know. Next, what is the critical angle of the material of the prism for blue color? Okay, so first one we need to understand the concept. If it is passing through the if it is passing on the surface, so that means angle of incidence is equal to the critical angle. But here angle of incidence is not given. So do you think this 133 is angle of incidence? No, we have to draw the normal. So normal, you keep the protractor here. Okay, normal will be somewhere here. The total angle is 133. From here to here is 133. Which angle do we want? This angle or this angle? See, that is very much important. Actually we want this angle. Why? Because what is angle of incidence? It is between the angle between the incident ray and the normal. So this definition you should know, the meaning of this definition. You should not just by heart it. Okay, this angle we want. This will be something different, correct? We don't want this angle. So the total angle is 133. Out of it some part we want. Okay, see, the total angle is 143 and we know from the normal and till the surface, see this one, This one is 90 degree, we can easily say. Why? Because from the normal till the surface it is 90 degree and total angle is 133. Out of 133, if you remove 90, this angle will be 43. This is angle of incidence. We know if the ray is on the surface, we know this is angle of incidence. Angle of incidence will be equal to critical angle. So answer for question A is I is equal to C is equal to 43. That's it. Next we will go for the second one. What is the measure of the angle of this prism? Okay, this prism angle of for this prism, where will be the angle of prism? We know angle of prism is always on the top, we know we can aramse say this is 90 degree, this is 90 degree. See, if you see this one, this is a straight line and this is also straight line. So this is a, if this is 90, this will also be 90. This is one way. Okay, if this is 90, we need to find this angle, then we can aramse find this angle, correct? So this is 90, we have to find this angle. See, from the surface, see, from the normal, from the normal, okay, this is the normal, from the normal till this, okay, till this it is 90 degree, correct? Till this it is 90 degree. So if the total angle from the surface till the normal is 90, out of that this angle is 43. Okay, 90 minus 43, it will be 47. So if this is 47 and this is 90, the total angle of a triangle will be 180 degree. So total angle is 180. 90 plus 47, and we don't know this angle, that we take it as x. The next value will be 43. So answer for B is also 43. Our next sub question: which color should be replaced by the blue ray for the ray to undergo total internal reflection? Listen, here many students will get confused. Okay, they will think if I replace blue color with the higher wavelength color than blue, they will get total internal reflection. Correct? Completely wrong. If you want total internal reflection, see, for this ray, blue color ray, it is going on the surface. Okay, so in order to get the total internal reflection, you should select the color. Okay, you should select the color which has lesser wavelength than blue. Keep this in mind. In order to get the total internal reflection, okay, blue anyhow it is not getting. Okay, so total internal reflection is blue is not possible in this case, correct? So in order to get the total internal reflection in this case, we have to select the color which has less wavelength than blue. So which has less wavelength than blue, that is indigo, okay, or violet. If you select any one, okay, you can write any one of these answer, indigo or blue, you will get total internal reflection. This point you have to keep in mind. This is very much important. These two with the knowledge you can get. This is little tricky. So again, this is a very base, complete depth knowledge. If you have, you can answer these kind of questions. Now we'll move on to 2025. In that first question, a rectangular glass block of refractive index 1.5. So refractive index is 1.5. As an air bubble trapped inside as shown in the diagram. There is a air bubble, okay, it is trapped inside a glass block. When seen from the surface AB, from surface, if you see from this angle, okay, somewhere here, okay, if you see from here, surface AB, it appears to be 4 cm deep. Appears to be, see, if they mention appears to be raised 4 cm, appears to be raised means it is shift. Okay, they have not mentioned appears to be raised. Appears to be 4 cm means it is apparent depth. Okay, appears to be 4 cm apparent depth. Appears to be raised, it is shift. That difference you should know. So appears to be 4 cm, so this is apparent depth. Okay, now these are the given data. Now we'll go for the question. Calculate the actual depth. Actual depth is nothing but real depth. Sometimes instead of giving actual depth or real depth, they will ask you to find the thickness of the glass block. This thickness of the glass block is nothing but the real depth only. Thickness is nothing but real depth. Real depth, actual depth, or the thickness of the glass slab. All the three means the same. So actual depth is nothing but real depth we need to find. So refractive index is equal to real depth by apparent depth. We want real depth, so it is refractive index into apparent depth. Refractive index is 1.5 and apparent depth is 4, so R will be 6 centimeter. You don't have to convert this into SI units, that is okay. Okay, so only when it comes to real depth and apparent depth, in work energy, power, and this one machines and all, you have to convert everything into SI units. Now first question is done. Second question, for which color of light, blue or yellow, they have given two options, blue or yellow, the apparent depth will be greater. So now we don't have a relation between apparent depth and color, direct relation between apparent depth and color. What do you mean by color? Color is nothing but wavelength, that you should know. Color means wavelength. Okay, out of which color has more wavelength, which color has less wavelength, that you should know. Okay, first we'll find the relation, then we'll go for which color has maximum and which color has minimum wavelength. For now we know blue, in the order Vibgayar. Okay, okay, this is, see, this has maximum wavelength, R has maximum wavelength, violet has minimum wavelength. So we are talking about blue and yellow. Okay, blue compared to one, we are talking about only these two. Yellow has maximum wavelength compared to blue, that you should know. Blue has minimum wavelength compared to yellow, that you should know. Okay, if this is useful, you can go for it. In the exam you do all these things. Okay, you do all these things in the rough work and get the answer, that is also fine. Now important thing is getting the correct answer. So now we got to know yellow has maximum wavelength, keep that in mind. Now wavelength and apparent depth, do we have the direct relationship? No. We know wavelength is inversely proportional to refractive index. Inversely proportional to refractive index. Here in the formula, how apparent depth and refractive index are related? They are talking about in this question apparent depth. Apparent depth is inversely proportional to refractive index. Then see, wavelength is inversely proportional to refractive index and refractive index is inversely proportional to apparent depth. See, this is how you need to understand that. Refractive index is inversely proportional to both wavelength and apparent depth. So apparent depth and wavelength are directly proportional. This relation is not there in the textbook. You have to analyze it. Okay, so now we got to know more the wavelength, more will be the apparent depth. So in the question they are asking which color, blue or yellow, apparent depth will be greater. Greater means more. So apparent depth is directly proportional to wavelength. Which color has more wavelength? Yellow color. So yellow color is the answer. This is how you need to analyze in the exam. See, there is no direct relationship, we derived it just now. So answer for question B is yellow. You don't have to show all these things. Okay, that is for your understanding. Yellow is our final answer. If you just write yellow, you will get full marks. No need to give the reason also, because they are not asking for the reason, so don't give one. We have one more sub question, that is part C, turning the glass block upside down. First you need to understand what is upside down. Turning it upside down, that means flipping it 180 degrees. See, this is 90 degree and 180 degree. Flipping two times, 90 and 180. So completely upside down. Okay, does not, they are giving one statement, does not change the apparent depth of the bubble. Listen, now this is the original position. Apparent depth is according to the question it is 4 mm, correct. Now if you flip it upside down, see, we'll take this as an example. See, the complete thickness of the pen is real depth. Okay, real depth. Now assume the bubble is at the end of this tip, the black color cap tip. Okay, here. So this is the apparent depth. So this is the apparent depth, and this white color is the shift. The complete thickness is real depth. See, this is apparent depth, the black color one. This white color one is the shift. Now what I'm going to do, I'm going to flip it. Okay, turn it at upside down, that is 180 degree, 90 degree and 180 degree. Now if you see from the same angle, this white, initially it was shift, now it becomes apparent depth. Now initially it was small, very small color, the black one. Now it has become big, the black color has shifted this side. So this becomes shift and this becomes apparent depth. This concept you should know. Okay, now once you flip it upside down or 180 degree, apparent depth, shift, okay, both will keep on changing. Now so they are giving this statement, when you flip it, does not change the apparent depth of the air bubble. State true or false. They are just asking us to state true or false. So it is false. It will change. The apparent depth shift, both will get interchanged, but real depth remains same. What is real depth? The complete thickness, correct? The complete thickness is nothing but the real depth. This is apparent depth and this is shift. Once you flip it, apparent depth and shift will get changed. This becomes apparent depth and this becomes shift, but the real depth remains same. So you need to understand what question they are asking, also what word they are using. Apparent depth and shift will get changed, real depth will not get changed. So here they are saying the apparent depth does not change. That is false. That is our answer. Our next question, two rays PQ and RS. PQ and RS are incident on a rectangular glass plate as shown in the diagram. Observe the diagram and answer the questions that follow. Which of these rays will? Okay, first we'll observe the diagram properly. Angle of incidence in both the cases same, 35 degree, 35 degree. So angle of incidence will not come into picture. Next, see the angle of refraction here. According to the diagram, the angle of refraction for PQ is more compared to RS. See, the angle of refraction is very less compared to this one. What do you mean by that? That means this ray has maximum wavelength compared to this one. Assume these two are two different colors. Okay, this has more wavelength compared to this one. That means it has more wavelength, means more speed. So this has more speed compared to this one. This is how you need to analyze. Okay, I have to see the angle of refraction. See here it is very small, here it is a little big compared to this one. So it has more speed. The PQ ray is more speed. This is the analysis we have to do before going to the question. Now we'll go for the question one by one. Which of these rays will have greater lateral displacement on emerging out of the block? So what do you mean by lateral displacement? Lateral displacement is nothing but, see, assume we don't have any this medium here. So this light ray would have moved in this angle. The light ray would have moved in this angle. Now in the same way, if you extend this one for this ray RS also, the distance between the refracted ray and the original path of light. See, this PQ, if there was no medium, this would have moved in this direction, correct? In this ray. So now what is lateral displacement? That is nothing but the distance from the refracted ray and the original path of light. Here see, now if there was no medium, this light would have gone in this way, correct? Now see the difference. This has less distance, this has more distance. So this distance is nothing but lateral displacement. First you need to know what is lateral displacement. The distance between the refracted ray and the original path of light. If there was no medium, the light PQ would have traveled in this way. So now this distance and that distance you have to compare. Which has more lateral displacement? That is RS. You just write RS, that's it. You don't have to write the ray RS as a larger lateral displacement. All those things not required. Just write the ray. Second one, travel with greater speed in the block. We already analyzed PQ has more speed because the angle of refraction is more. So PQ, then sub question C, scatter more in the atmosphere. So what do you mean by scattering? Scattering is nothing but, okay, it is related to wavelength. Okay, so it is inversely proportional. Okay, more the wavelength, less will be the scattering. More the wavelength, less will be the scattering. These two are inversely proportional, that you should know. Okay, now which color has more wavelength here? We initially got to know more the speed means it has more wavelength. So it has more wavelength, so it has less scattering. See, here we have more speed, we got to know more speed is because of more wavelength, that means it has more wavelength, so it has less scattering. What is the question? Which scatters more in the atmosphere? That means it should have less wavelength, then scattering will be more. So here the speed is less, that means wavelength is less. If the wavelength is less, scattering will be more, because scattering and wavelength are inversely proportional. Again the answer is RS. See, if you have the concept, within 1 minute you can get 3 marks. Our next question, a ray of light enters a rectangular glass slab submerged in water at an angle of incidence 55 degree. See, there is a ray of light, okay, entering, and there is a glass slab which is inside the water. Now listen. So this is the water, there is a glass slab, okay, rectangular glass slab, a ray is entering because of the refraction. See, this diagram is not required, okay, it is going to incident here at an angle 55 degree, that is given in the question. Now, does this ray undergo total internal reflection when it is moved from water to glass? Now the ray is moving from water to glass, they have clearly mentioned. When it is moving from water to glass, justify your answer, and the critical angle of glass water is 54, okay, angle of incidence is 55, critical angle is 54. Now according to the textbook, okay, if the angle of incidence is greater than the critical angle, then definitely it should undergo total internal reflection, correct? No, this is the secondary criteria. Secondary, this is correct, but this is the secondary criteria. What is the first criteria? What is the first condition? The ray has to move from denser to rarer. The ray has to move from denser to rarer. See the question, does this ray undergo total internal reflection when it moves from water to glass? Water to glass. When it compared to water and glass, which is denser? Glass compared to water, correct? So the ray has to move from denser to rarer, but here it is moving from rarer to denser. There is no need of thinking about the angle. This is correct, but this is the secondary condition. What is the primary condition? The ray has to move from denser to rarer, but here the water, it is moving from water to glass. Water is rarer and glass is denser. We are not talking about air and water, we are talking about water and glass. Okay, here you need to see which is denser and which is rarer. So now we'll answer, does this ray undergo total internal reflection? No, and we have to give the justification. For total internal reflection, see, you have to write like this. For total internal reflection, the ray has to pass from denser to rarer, but in this case it is moving from rarer to denser. That's it. Now we'll go for our last question. Out of 3 rays, I, J, H, okay, I, J, H shown in the diagram, which ray will suffer total internal reflection while inside the prism? Critical angle of the glass prism is 42. Critical angle is 42. We need to find. See, first question is just to identify. Okay, just to identify which ray out of these, okay, will undergo total internal reflection. See, when it comes to these kind of questions, most of the students will think, okay, out of these 3 rays, only one will undergo total internal reflection. So if they don't know the topic, they'll go for inky pinky ponky. Correct. Sometimes there is a possibility that all the 3 might undergo total internal reflection. For that, we need to have that knowledge whether it is undergoing total internal reflection. We have to draw. Okay, first we'll go for H. Okay, I, J, H, I, J, right? We'll go from first letter, that is H. Okay, now it passes directly here. Okay, so it passes, we'll go one by one. Okay, after I finish one, I'll erase it so that there will be no confusion. Okay, now listen, H, okay, I have passed because without deviation it has passed because the angle of incidence is 0. Now before going to this topic, okay, you have to see whether all the angles are given. This is 90 and this is 60. This is definitely 30. Why? Because the total angle of a triangle is 180 degree. This is 90 plus 60, 150, 150 plus 30, 180. That you should know. Okay. Once it is passed, now we have to see, we have to keep the protractor. We have to keep the protractor and draw the normal. This angle we want. This angle we want. Correct? Because this is the angle of incidence. So to find this angle, we need to know this angle. Correct? See, this is 90 degree. This is 30. So 90 plus 30, 120. The total angle of a triangle is 180. So out of 180, 120 is these two angles. This will be 60 degree. Okay, this will be 60 degree. And from the normal till the surface, it is 90. Right, from the normal till the surface, it is 90. So total angle is 90. Out of 96, one is 60. The remaining is 30. Okay, now the angle of incidence is 30 degree. If the critical angle is 42 degree, see, angle of incidence is less than the critical angle, so it will not undergo total internal reflection. What is the condition for total internal reflection? Okay, the angle of incidence, okay, should be more than the critical angle. So here the angle of incidence is less. It is 30 compared to critical angle, so it is less, so it will not undergo total internal reflection. So H is not an option. Okay, H will erase it. See, for the first sub question we don't want diagram. Only for the second sub question we need a diagram. Okay, then we'll go for I. Okay, so anyhow it is angle of incidence is 0. It passes without deviation. Okay, wherever it touches, we have to keep the protractor and we have to draw the normal. We require this angle. We require this angle. See, we know see, this is a triangle, correct? If we know it has passed straightly, so this is also 90. If this is 90 and this is 30, this should be 60. This should be 60. But do we want this angle or this angle? We want this angle, correct? So because this is what is angle of incidence? It is the angle between the incident ray and the normal. This angle we want. So the total angle is 90 degree, out of which one part is 60. So this will be 30. So angle of incidence is again 30. It is less than the critical angle. So it will not undergo total internal reflection. Now there is a possibility that all the three angles may not undergo total internal reflection. That is also possible. So if you check only two, you should not leave this third one. You should check this one. Answer might be none of this. So we have to be very careful. Now anyhow angle of incidence is 0. It passes without deviation. Okay, wherever it touches, keep the center of the protractor and draw the normal. So normal, this angle we want. This angle we want, correct? Because this is the incident ray and this is the normal. Angle between them is the angle of incidence. Now listen, this angle we want. How we can find this? This ray has created one triangle, correct? We got to know this is 90, so this is also 90. If this is 90 and this is 60, so 150 and this will be 30, because total angle of a triangle is 180 degree. Okay, if this is see, from the surface till the normal is 90 degree, out of total angle is 90 degree, out of it some part is 30 and this will be 60. Now the angle of incidence is 60 degree, which is more than the critical angle. So angle J undergoes total internal reflection. In the exam you will not take this much of time, because I am explaining here everything. I am explaining here, correct? For drawing something I am taking so much of time just to make sure you are understanding everything. In the exam, just for a rough diagram, you don't have to do this much explanation and all. You can directly draw it faster, in a faster way. Now if the angle of incidence is greater than the critical angle, it undergoes a total internal reflection. So if this is 60, angle of reflection will also be 60. Whenever it touches here, draw the normal and we want this angle. We want this angle. So how to find that? See, this is how to find this angle? We have to find this angle, correct? How to find this angle? This ray has created one triangle. So this is 90. See, this is 90, and we know from the normal till this surface it is 90. One angle is 60, this one will be 30. If this is 30, okay, this will be 60. If this is 60, so see, from this surface till the normal total angle is 90 degree. Total angle is 90 degree, and out of which some part, okay, this is 60 and this will be 30. So this will be 30. If this is 30, angle of incidence is 30, it is less than the critical angle. So total internal reflection, now it will not undergo, it has undergone already. So now it will come out of the prism. Now to come out of the prism, again there are three possibilities: passing straightly, passing towards the normal, and passing away from the normal. Now see, passing in a straight way it is not possible because there is a change in medium. Now whether it goes more towards the normal or away from the normal, here also you may lose 1 mark. Okay, so how? If it is passing towards the normal, the speed has to reduce. If the speed is getting reduced, it will move towards the normal. If the speed is getting increased, it moves away from the normal. Correct? So it is moving from glass to air, denser to rarer medium. Okay, it is passing. So the speed increases. If the speed increases, it moves away from the normal. So this is our final answer. Okay, in the exam you can write it directly. I drew the 2 extra rays just to make sure you understand the concept. So this is the diagram they are looking for. So answer for A is J, answer for B is the diagram. This is the diagram. That's it. Now we have completed all the questions from the chapter Refraction of Light at a Plane Surface from 2017 to 2025. From 2026 onwards, I am going to give you the solution, okay, chapter wise in one complete video of 2026 paper, because we are currently in 2025. I cannot get the paper of 2026, correct? So I don't have a time machine. Now this is the solution. So what is the correct procedure to learn a particular chapter? Concept video, theory solution videos, numerical videos, then previous year papers. This is the previous year paper. After this one, directly go to the logical and application based question papers. So that is there in the description box. Again, that is chapter wise, only based on refraction of light at a plane surface. We have done logical and application based. So do you think we are taking the questions randomly? No, we are taking the questions from specimen papers and competency based question papers that was released by ICSE. ICSE is nothing but ICSE board only. So they have released these papers. Using these papers, we have segregated all the questions chapter wise, logical and application based questions. All those videos are also available in the description box. Watch everything. Learn from one chapter. If you learn in this way, you will get the complete knowledge, so that you are ready for the board exam. Thank you.